Hello everyone. In this video, I'm going to give a brief introduction to what the Ethereum blockchain is and some of the key terminologies related to the Ethereum blockchain. Before starting, I would like to quickly introduce myself. I'm Amrisha Kakoti and I'm working as a software engineer at Kpro Solutions Private Limited. Kpro is a leading provider in data lake, cloud implementations, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile application development. So without any further ado, let's get started with today's video. So the topics we'll be covering in this video are what is the Ethereum architecture, what are Ethereum nodes, Ethereum accounts, and finally how transaction happens in Ethereum. But before proceeding, we should know a few terminologies related to the Ethereum blockchain. So the first one is external actor. So this external actor is a person or any other entity able to interface to an Ethereum node but external to the world of Ethereum. It can interact with Ethereum through depositing signed transactions and inspecting the blockchain and associated state. It has one or more intrinsic accounts. The next one is address. So it is a 160-bit code used for identifying accounts. The next one is account. So accounts have an intrinsic balance and transaction count maintained as part of the Ethereum state. They also have some EVM code and a storage state associated with them. Though homogeneous, it makes sense to distinguish between two practical types of accounts. So the first type of account has an empty associated EVM code and the second one has a non-empty associated EVM code. Next, let us see what is this transaction. So this transaction is a piece of data signed by an external actor. It represents either a message or a new autonomous object. Transactions are recorded into each block of a blockchain. Next is autonomous object. So this autonomous object is a notional object existent only within the hypothetical state of Ethereum. It has an intrinsic address and thus an associated account. The account will have non-empty associated EVM code incorporated only as storage state of that account. Next, let us see storage state. So it is the information particular to a given account that is maintained between the times that the account's associated EVM code runs. Next one is message. Data and value that is passed between two accounts either through the deterministic operation of an autonomous object or the cryptographically secure signature of transaction is called message. Next one is message code. So it is the act of passing a message from one account to another. Next, let us see what is gas. So it is the fundamental network cost unit paid for exclusively by Ether, which is converted freely to and from gas as required. Gas does not exist outside of the internal Ethereum computation engine. Its price is set by the transaction and miners are free to ignore transactions whose gas price is too low. The next one is contract. So it is an informal term used to mean both a piece of EVM code that may be associated with an account or an autonomous object. The next one is object. So it is a synonym for autonomous object. The next one is application. So it is an end-user visible application hosted in the Ethereum browser. Next one is Ethereum browser. So it is a cross-platform GUI of an interface similar to a simplified browser that is able to host sandbox application whose backend is purely on the Ethereum protocol. The next one is EVM or the Ethereum virtual machine. So it is the VM that forms the key part of the execution model for an account's associated EVM code. Next one is ERE or the Ethereum runtime environment. So it is the environment which is provided to an autonomous object executing in the EVM. It includes the EVM but also the structure of the world state on which the EVM relies for certain IO instructions including call and create. Next one is EVM code. So it is the bytecode that the EVM can natively execute, used to formally specify the meaning and ramifications of a message to an account. Next, and the final one is the EVM assembly. So it is the human readable form of EVM code. So these were a few terminologies that we needed to know before proceeding further regarding the Ethereum blockchain. Next, let us see the Ethereum architecture. So this is basically what the Ethereum network looks like. So it has the mining nodes and the EVM nodes. So these mining nodes will have the entire copy of ledger starting from the first block ever created to the most current block. And this EVM node will have the smart contract. So this smart contract helps in extending Ethereum in writing custom business functionality into it. The smart contracts can be executed as part of a transaction and it follows the process of mining. So when a person makes a transaction or sends a message, it invokes a function within the smart contract. The transaction is digitally signed with the sender's private key to ensure that the identity of the sender can be established while verifying the transaction and changing the balances on multiple accounts. So this is all about the Ethereum architecture. Next, let us see what are the Ethereum nodes available. So the first one is EVM or the Ethereum virtual machine, and next one is mining nodes. Although in most scenarios there is no dedicated EVM, instead all nodes act as miners as well as EVM. Next, let us see what is the Ethereum virtual machine or the EVM. So EVMs are primarily responsible for providing runtime that can execute code within smart contracts. It can access accounts both contract and externally owned and its own storage data. EVMs does not have access to overall ledger but does have limited information about the current transaction. And as EVMs are execution components in Ethereum, the purpose of EVM is to execute the code in a smart contract line by line. However, when a transaction is submitted, it does not get executed immediately. Instead, it is pooled in the transaction pool. So the transactions that are pooled in the transaction pool are not yet written in the Ethereum ledger. So this is all about the Ethereum virtual machine. Next, let us see mining nodes. So this mining nodes mines or creates a new block with transactions and writes the same to the Ethereum ledger. They also advertise and send newly mined blocks to all the nodes present in the network to get them validated by them. And they also accept new blocks mined by other miners and keep its own ledger instance up to date. It's all about the mining nodes. Next, let us see what are the different Ethereum accounts available. So there are two types of Ethereum accounts. The first one is the externally owned accounts and the second one is the contract accounts. Let us first see what is the externally owned accounts. So these are the accounts owned by the people on Ethereum. When such account is created by an individual, a public and private key is generated. The private key is kept safe with the individual, whereas the public key is broadcasted in the network. These accounts hold Ether in its balance and does not have any code associated with it. It can execute transactions with other externally owned accounts and it can also execute transactions by invoking functions within contracts. Next, let us see contract accounts. So these are very similar to the externally owned accounts and they are identified using their public address. They do not have a private key and even these accounts can hold Ether similar to externally owned accounts, but they contain code for smart contracts consisting of functions and state variables. Now let us see how a transaction happens in Ethereum. So whenever a new transaction is made in the network, it propagates in the network and gets added to the transaction pool maintained by the miners. So these miners collect the transactions from the transaction pool and add them to a block in order to create a block. But in order to create a block, the miners need to solve a puzzle. So these miners compete among themselves to solve a puzzle. So the first miner that succeeds in solving the puzzle broadcasts the block to all other nodes present in the network in order to be validated by them. Once it gets validated, the miner receives the award and all the nodes present in a network adds that validated block to their own copy of ledger. And in this way, a transaction gets added to the blockchain. Now let us have a quick recap of the topics that we have covered in this video. In the beginning, we talked about a few terminologies related to the Ethereum blockchain. Then we talked about the Ethereum architecture. Then we saw what are different types of Ethereum nodes, where we talked about the Ethereum virtual machine and the mining nodes. Then we talked about the different Ethereum accounts, which are the externally owned accounts and the contract accounts. And finally, we talked about how a transaction happens in Ethereum. Thank you for watching this video. In the next video, that is Introduction to Solidity Part 1, the topics I'll be covering are Ethereum virtual machine related to Solidity, Solidity and Solidity files, pragma, comments, import statement, and contract. Kindly provide your valuable feedback in the comment section below and let us know of any topic you want us to make a video of or any issue you might be facing in your project. You may write to us at feedback@kpro.co.in. You can even subscribe to our channel to learn more about blockchain, cloud, data science, ETL, data lake, DevOps, big data testing, cloud testing, and you can also follow us on YouTube, Facebook, LinkedIn, and Twitter. Thank you very much. Let's keep learning.